Hi, this is Sarah Stromness, and this is my video showing my Science Brain activity number 2 on simple machines. So I'm doing a lever, and this is a video of the lever I created in AlgoDo, and as you can see, it's pretty simple. It's just, it's pretty simple, and this is what I'll be referring to for the rest of this video. So the first thing I have to compute is the maximum power of the lever that I just barely showed you. So the equation for maximum power is force times the change in distance or displacement times the cosine of theta over the change in time. And I'm changing that to be the force times the velocity times the cosine of theta, which is the same thing. So the value of force is the product of the mass of the object and the acceleration of gravity. There are various types of levers, and in the example I will be showing, the force of the object, which is a box, will be the mass of the object, and if the lever is a seesaw, then the force of the object will be the force which the person is pushing downward on the side. On Earth, the force of gravity is 9.8 meters per second per second. So the force is the mass times the acceleration, and in this case we are assuming that the mass of the object is 1.0 kilograms, and that is what we found in AlgoDo, and the acceleration is 9.8 meters per second, and that is assuming that the mass of the lever is negligible. So that comes out with the force being 9.8 newtons. So the maximum force will occur at the maximum velocity. And next is time. The distance the lever will drop is 1 meter. And to solve for the time, given the equation, distance equals half acceleration times time squared. And the displacement, there are two equations. So first is the one we'll be using, which is displacement equals 1/2 times acceleration times time squared, and that is what we'll be using, and that is when the velocity beginning is 0. And then the other one is distance equals half acceleration times time squared plus beginning velocity times time, and that one's more universal, but we are using the first one. And so here's what we found. So it's 1 meter equals 1/2 times 9.8 meters per second squared times time squared, and that is, you can see the calculations we did here, and it came out with t equals 0.452 seconds. So the maximum velocity is going to be 4.4296 meters per second. And for the cosine of theta, we are assuming that the cosine of theta is close enough to 1 for our purposes because it looks like a very small angle. And this is the equation again. So 9.8 newtons, which is the force, times 4.4296 meters per second, which is the velocity, or the distance over time, times 1, which is the cosine of theta. And that computes to the maximum power being 43.41008 watts. So next we compute the efficiency. So to find the efficiency of anything, you find the energy output and divide that by the energy input and multiply that by 100%. So to find the energy output, you use the equation kinetic energy equals 1/2 times mass times velocity squared. And then to find the energy input, you use the equation potential energy times mass times the gravity times the height. And so these are the values we found. So again, the 1.0 kilogram is the mass, and that's assumed, but that is the weight of the box on the lever. And then next is the velocity, which we found on a previous slide. And then the gravity is 9.81 meters per second. And then the height is 1.0 meters, and that is from AlgoDo. We found that. So next is to find the energy output. So we'll substitute those values in. 1/2 times 1.0 kilograms times 4.4296 meters per second and squared, and that comes out with the kinetic energy, or the energy output, being 9.81067808. And then to find the energy input, we substitute those values into the energy input equation, and it is 1.0 kilograms times 9.81 meters per second times 1.0 meters, and then that comes out with being 9.81. And I forgot to put it on the slide, but the units for that are joules. And then we put those into the efficiency equation, and so 9.81 0.67808 divided by 9.81 is very close to 1, and times that by 100%, and so the efficiency of the lever I created is 100%. So that is the conclusion. Maximum power for the lever is 43.41008 watts, and the efficiency is 100%. Thank you for watching.